Welcome to in this TGR video content session. So as we know, we are already discussed previous about our admission process. So as we know, the last date for the regular entry was 25th July 2022, and right now one entry is left, that is our lateral entry. So you should enroll yourself for the lateral entry. As we know, we already mentioned what is the last date for lateral entry. So I think so same problem again arise, that is जब भी मैं बोर्ड क्लीन करना चाहता हूँ तो ज़्यादा पानी का इस्तेमाल हो जाता है. So I think so I need to search any solution for this problem. So anyway, सो मैं एक बात क्लियर कर देना चाहता हूँ कि जो हमारे नियर अबाउट सिटी के जो भी रेसिडेंट है, जो भी हमारे स्टूडेंट है, वो डायरेक्टली यहाँ पे विजिट कर सकते हैं. ऑलरेडी कितने तो भी वीडियो पे ऑलरेडी हमने हमारा इंस्टीट्यूट का एड्रेस दे दिया है. अगेन आई वांट टू रिपीट दिस सेम एड्रेस. सो एड्रेस इज दैट अबोव पंजाब नेशनल बैंक, ड्रीम्स लैंड बिजनेस पार्क, नागपुर हाईवे रोड, अमरावती. यहाँ पे सीधा आप विजिट करिए और आपको जितना भी ये कोर्स इंफॉर्मेशन है आप हमारे जो एडमिशन डिपार्टमेंट है उनसे आप कांटेक्ट करके ओवरऑल इसका इंफॉर्मेशन ले सकते हैं कि हमने किस कोर्स में खुद को एनरोल करना चाहिए. सो आई वांट टू lateral entry. As we know, the last date for the lateral entry is तो ये हमारा लास्ट डेट है और ये जो लास्ट डेट है वो है 5 PM up to 5 PM. So please confirm your admission within a time limit. As we know, late fee is applicable for this lateral entry. So I think so one good news is here, that is we have guest for the solar energy course. So this sir have the very special skill related to our manufacturing process of PV module. As we know, PV module is the major component for generation of our electricity. So I would like to introduce about this sir. The sir is Mr. Vishal Gawhale sir. Sir,
hello friend.
Welcome in this video.
Thank you sir.
So I would like to introduce about your profile, so that our audience or our student can be understand what is the major role of PV module for the generation of power with the help of solar energy. So as I listen, I have idea about the sir skill in particular sector, that is our solar sector. So sir have experience of overall manufacturing process of PV module. So please sir, please give in short of brief about this process.
First of all, I should introduce myself. My name is Vishal and I am an electrical engineering student. I still say that I am the student because I am the learning. My journey is never stop in the electrical field. I have the experience of solar module manufacturing, in which I work as a supervisor and also as a operator. So first of all, I like to say about the solar. Why I go toward the solar industry? The today's world, our energy need is never to be end, and non-conventional energy source are some time after they will be end. There is a not for the lifelong. So I decided I go to the solar industry, and I like to be say about my experience, my working experience in the solar industry. I can't be say about my company name, but I will be say all about the information regarding the manufacturing. First of all,
Should I stay here?
okay, cotton.
Cotton is here. No, this is temporary pen.
Okay. Friend, the solar energy we are utilized in the current day with the help of the solar cell, which is the origin from the semiconductor. First, our step is the semiconductor. The semiconductor is a material which either be conductor or the insulator, but they have a change their property of the conducting, non-conducting, because there are the valence band is electron is moved to the conduction band. So they are the property we are changing. The semiconductor is the origin point of our solar, and semiconductor are further divided. It is a intrinsic and extrinsic. Intrinsic is a pure, and it is a impurity. It is a impurity added. Then in the solar system we are use the extrinsic semiconductor, which is the impurity added in the pure semiconductor, like germanium and silicon. They are the mostly used the semiconductor in our industry. The silicon is mostly preferred because their breakdown voltage is the greater than the germanium, and the minority charge flow is a too minimum. So we go with the silicon. The pure, there is a silicon. Silicon is a pure semiconductor. Silicon is a pure semiconductor. We need to add some impurity in which to create a two polarity, so that we add the impurity pentavalent and trivalent. The silicon plus pentavalent impurity and silicon plus trivalent impurity. The pentavalent impurities means they have a 5 electron in the outer cell. For the completing the valence band we need only 4, but 1 electron is extra. Thus 1 electron we treat as a N-type semiconductor. So this is called N-type. And also the trivalent, the outer cell has the 3 electron and 1 cell is the remaining, that is the hole. The vacant cell we are called as a positive semiconductor, means p-type. This is the 2 types of semiconductor we are rich from the semiconductor origin of the solar. Now at a time we are junction it combined together, and one type have a 1 electron extra and other have a valence hole, means they have a place for the electron. One have a extra, one have a needs. So as expose this junction toward the sunlight, they are transfer the extra electron to the p-type. That's the called the current is low. They are being used in the solar system. This is the single model we are consider, but the solar cell is not actually as a practical. Theoretically we are studying in our school, college. It is different from that. The solar cell is nothing but a p-n junction semiconductor which have a large cross-sectional area which exposed toward the sun. We show in the diagram what is the solar cell. this is our p-type. This is our p-type layer which we are understand before that. This is the semiconductor silicon. Put the impurity of the trivalent, pentavalent, p-types in which we are add the pentavalent impurity. We are add in the semiconductor of silicon. We are adding the trivalent impurity in the p-type, and we need the another one junction, n-type, junction for the flow of the electron. We add the another layer of the n-type. This side has a positive carrier and this side has a negative majority carrier. The current is flow from the positive to negative, but in actually the electron is flow from the negative side to positive. That is the convention, that is the actually electron flow. But we are studying in our books the current is flow from the positive to negative. That's called the conventional. But actually the current is flow from the negative side to the positive side, electronic current. But that is the name is the electronic current. I think you understand this stuff. How we take a semiconductor, after the semiconductor types, intrinsic, extrinsic. Extrinsic semiconductor is impure. It is a impurity is added in the pure semiconductor. That's two form, p-type and n-type. The p-type is the positive, they are adding the trivalent, and n-type is the negative, which is adding the pentavalent, extra electron. After that is a p-n, they are combined together and form the junction, that is called the junction. And this is the semiconductor finally. We are actually positive.
Okay. So
now we are understand about the models. How is the model we are manufactured in the industry? The model manufacturing is a part of the solar industry. First, we the manufacture semiconductor, then the cell, then the model, then installation. This is the whole life cycle of the solar industry. So now we see the how we are model is the manufacturing. We come from the semiconductor to the cell. Cell is the formed by the junction PN. From now we see from the junction PN junction cell toward the model. We know that what is the cell? Cell is the PN junction of semiconductor. And this PN junction cell we are connect in the series to increase the voltage. The single cell are able to produce the 0.5 volt, but it is not enough to produce or to develop the enough amount of the energy. So now we are use the number of the cell are connected in series by adding this voltage. So this is the cell, and this cell is added by the series connection in this number of the this to this and this. This is the plus sign, that is a minus sign. We know that the single cell are produced the 0.5 volt. At here I take only 3 cells, but in the actual we are take the 72 cell, 36 cell, which is a produce the 12 volt, 18 volt and 36 volt, which is the industrial level. So I take the 3 cell for your understanding. This cell is the produce the 0.5 volt. This is the 0.5 volt and it is a 0.5 volt. This is 0.555. It is equal to total voltage is equal to 1.5. This voltage is enough to glow the small LED. You are getting me understanding what I say. We not use the single cell. We use the number of cell, but not in parallel. It is mostly used in the series because the cell have a low voltage and their ampere is in the rate of the 10 ampere, 9 to 10 ampere are developed by a single cell, but the voltage is less. We are improve that the voltage. This is the number of cells are joined together. This process is done by the stringer. Stringer is an automatic machine which is the combined number of cells in the form of the string, and we look like that. The single cell, the number of cells. After this is the string, we are pre-module manufacturing process. There is a take a tempered glass which is a high transparency, and then put on the EVA. EVA is nothing but a polymer which is the stabilize the our cell and long life for that. We are envelope sandwich the solar cell between the two EVA sheet. It's like that. This is the glass. That is the EVA. That is the our solar cell. That is the EVA, and that is the backsheet. That is our module, which are the finally see. And backside of this backsheet we put. We are fixed the JB, which is taken out the junction. Means the power developed will take out from the result junction. This is our the module. What we do? We are understanding. I say we are manufacturing the string. After the string, I put on the glass with the help of the EVA. Glass, EVA, and they are on the string. That is, the string is not in the random manner. First is a positive, negative string, which is utilized for the series connection. It is a better when we use the series. In plus minus relation, we need the less amount of the copper for the soldering. After we placing, that is a glass, after we placing this string, that's manner, we are connect this string. They are the string. This is the string. This is the string. And these strings are connected with the another string in the manner of the series connection. And that string connect. And this string connect, then, and then. It is a series. All strings are connected in series. Also that we have a 72 cell are series connected. That means they have a 36 volt, which is 1 cell are produced, the 0.5 volt. So, and we say that it is a module. It is a module, but without laminated. Cell, glass, cell, and EVA backsheet.
So, sir, we need to stop here. So, as we know, this session was the introductory session by the Mr. Vishal sir.
Thank you.
So that's why, as we know, we are little bit getting unclear idea about the process of manufacturing by the Vishal sir. So if you vote for the Vishal sir, whether Vishal sir should taken this syllabus or not, you should vote for this concept, for this very practical aspect of teaching, because Vishal sir collect experience by practically doing this thing on the practically means we can say in the industry. So that's why we cannot read this experience in the any book present on the we can say any syllabus. This is any practical manner. So that's why you need to vote for the Vishal sir, so that Vishal sir can continue for the valuable content, so that you can achieve your goal in the solar energy sector. So I think so. And one thing is please clear for us what language you have suitable for the understanding of this overall knowledge. So please tell us about this idea, whether Vishal sir should teach in English or we can say in a regional language, that is Marathi. Vishal sir speak very well Marathi also as well as English also, but we need to your opinion. What is the comfortability of your understanding? So all guys, thanks for watching. I would like to say to again Vishal sir, thank you for give us such a valuable information related to solar.
Thank you, give me the opportunity to give you the knowledge. Thank you, Vishal sir.
Okay sir. So I would like to stop here for this content. I will show this content number 20 or 21, whatever. So I would like to repeat again. Please confirm your seat for the lateral entry. I have already told the lateral entry last date is the 25th August 2022. Alright, we need to stop here. Please like and share across your family, relatives, or we can say in the friend circle. Thanks a lot. Keep watching TGRL. Keep learning. Keep growing. Okay. Thanks a lot.